All right, today we're going to be looking at perfect squares. Now you may be thinking geometry again and say, hey, every square is perfect. It has four equal sides and has four angles that are also equal. But when we look at perfect squares are a little bit different than imperfect squares. For instance, as you can see here, I have what we would call a perfect square that has a 6 by 6 dimensions. Now, if we go ahead and look at something that's imperfect, would be something that would be if I would start maybe down in this bottom right hand corner, I would start like right here. Maybe it's 2.5. And then I would go all the way up here to this square here, back over to here. Whoops, actually, it would go 2.5 here. See, it's kind of hard to draw these imperfect squares. And the reason why we call them imperfect, I mean, we can say this is 2.5 and this is 2.5. So I do have a square here that happens to be a 2.5 by 2.5, a square. That would be the dimensions of it. Now the area, because I happen to have this memorized, is 6.25. So this would be our 25. Whoops, get rid of this. We got 22.5 squared. So it's 6.25. But when we're just looking at this here, I know I do have 1, 2, 3, 4. I have 4 squares. And then you could say, well, then this here, since these are half each, this would be a fifth of a square, this would be a sixth square, and this would be your 0.25. So that's where we can look at 6.25. So, but that's not a perfect square. It is a square, but it's not a perfect square. When we look at perfect squares, we look at squares that actually have a whole number, actually an integer. That's just not a whole number. Let's take that again. Not a whole number. It actually is a natural number, 36. So this has 36 squares. Other type of perfect squares look like this. This has 4 squares in it. 1, 2, 3, 4. This one has 9. This one has 16. So they have those integers. That's why we call them perfect squares. They don't have 6.25 or some kind of number that might be some kind of decimal fraction. These are actually perfect squares in here.